Exponential growth or decay is used when things grow or die quickly. A growth, you'll have a growth graph will look like this. A decay graph will look like this. Now the exponential equation is f of x equals a parenthesis b to the x. B is the base, x is the exponent. Now if b is greater than 1, we know it's a growth. And if b is in between 0 and 1, it is a decay. So how do we graph exponential functions? Well, we first decide whether it is a growth or a decay, so we make sure our graph looks like it's supposed to. We pick x values -2, -1, 0, 1, and 2. We plug in using our calculator and solve, and then we plot the points. So looking at example A, we know that this is a growth. How do we know that this is a growth? Because this number right here, 1.5, is bigger than 1. So I'm going to use -2, -1, 0, 1, and 2 as my x values. And I'm going to go ahead and plug those in. So 1.5 to the -2 power is 0.69. 1.5 to the -1 power is 2/3. 1.5 to the power of 0 is 1. 1.5 to the power of 1 is 1.5. And 1.5 squared is 2.25. So just do your best when graphing this. It doesn't have to be perfect. Just make sure that the growth is shown. Don't go below your x-axis. For example B, this is going to be a decay. How we know it's a decay is because this number right here is less than 1. So we pick our x values, -2, -1, 0, 1, and 2. We fill it in. 0.5 to the -2 power is 4. 0.5 to the -1 power is 2. 0.5 to the power of 0 is 1. 0.5 to the power of 1 is 0.5. And 0.5 squared is 0.25. So we're going to go ahead and plot that. -2, 4. -1, 2. 0. Oops, sorry guys, right there. See if I can get rid of this little guy. No. Well, we'll just ignore that. 1.5 and then 2.25. So just pretend like that one isn't there. That one. This guy was a mistake. Okay. All right, moving forward. So this, again, we're looking at this number to make sure whether it's a growth or a decay. So this is going to be a decay because that is less than 1. We're going to pick -2, -1, 0, 1, and 2 and fill that in. So 0.8 to the -2 power, and then I times that by 30. We get 46.9. 0.8 to the power of -1, and then I times that by 30, we get 37.5. This would be 30 because 0.8 to the power of 0 is 1, and 1 times 30. 0.8 times 30 would be 24, and 0.8 squared times 30 would be 19.2. So now, granted, we can do these by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45. So -2, 46.9. -1, 37 would be somewhere here. Change the color here. 0, 30, 1, 24, and then 2, 19. So this would look like this. All right, so we have two interest formulas. One is for when it's compounded interest. The other one is important, is compounded continuously. So when you see compounded continuously, that's when you know to use APERT. So here we go. So for this formula, A is the ending amount. P is your starting amount, also known as principal. R is the rate without percent. N is the number of times per year. And T is the time, and that's going to be in years. Now, just so you know, monthly is 12 times a year, quarterly is 4 times a year, and annually is 1 time a year. Think of sales. If they have quarterly sales or if you have a monthly bill, you do every month. Now, compounded continuously, that's a little different. It's going to say it in the instructions. So P is still the starting amount. E is the button in the calculator, and that can be found right above the LN button. Rate is the rate without percent, and time is time in years. So if we look at our first example, it says you decide to invest $8,000. So my $8,000 is going to be my principal, my initial amount. 6 years, that's another one. That's going to be my time. Okay, so you want to... The first pays 7% compounded monthly. So, okay, 7% is going to be my rate. Oops. There we go. So this is going to be my rate. Now I'm going to have two equations here. My first one, it says compounded monthly. So compounded monthly means that it's going to be 12. That's my N. So here we go. So we have the amount at the end will be my initial amount of 8,000, and that's going to be 1 plus. Now my rate is 7%, so if I change that to a decimal without a percent by dividing it by 100, I get 0.07. Then I'm going to divide that by the number of times per year, which is 12 because it's monthly, and then I'm going to put this to the power of N times T. So in my calculator, I'm going to do 0.07 divided by 12 equals, then I'm going to add 1 to that, put that to the power of 12 times 6 using parentheses, which is 72, and then times it by 8,000. Remember PEMDAS when you're doing this. So at the end, you're going to have $12,160.84. Now the other one says that it's 6.5% per year. Let's switch it here. So 6.5 compounded continuously. So it's still the same amount starting. So because it's compounded continuously, we have to use the other formula. So A equals PE to the RT. So the 8,000, the E button in my calculator, my rate is going to be 0.0685, because remember we have to get rid of that percentage by dividing that by 100, and then times the time, which is 6 years. So this you're going to hit in your calculator, your second, and then the ln button. That's going to give e to the power. You're going to put in 0.0685, excuse me. So second e, second ln, 0.0685 times 6. And then that's going to be 1.5 and then a long decimal and times it by 8,000. So at the end here, you're going to have $12,066.60. So which one is the better investment? Well, the better investment is the one with the most money in it, which would be this one right here. Okay, so suppose you have $12,000 to invest. Which investment yields a greater return? 7,000 compounded monthly or 6.85 compounded continuously? So again, for the monthly one, we're going to use the first formula. So my ending amount, my initial amount is 12,000, parenthesis, 1 plus, my rate would be 0.07 divided by the number of times per year, which is 12 because it's compounded monthly. And then that's going to be 12 for 3 years. So in your calculator, it's 0.07 divided by 12 equals plus 1 equals to the power of 12 times 3, which is 36 equals, and then times it by 12,000. So for this one, it's going to have $14,795.11 when I round that last decimal. Now remember, because it's money, we're rounding to 2 decimal places because we can't have pay with anything more than cents. So my next one, it says we have 7% or 6.85% compounded continuously. So remember, when it says this compounded continuously, we know we're going to use a PERT. So my principal is 12,000. My E is the E button in my calculator. We're going to change this rate to a decimal without a percentage sign, and we're still using 3 years. So again, you're going to hit second and then the LN button. That's going to prompt E, 0.0685 times 3, and then times that answer by 8,000. Not 8,000, 12,000, I apologize. I was looking at the last problem. So then we have 20,000. Let's just double check that. Second ln 0.0685 times 3 times 12,000. So this one gives me $14,737.68 when I round correctly. So which one is the better investment? It's close, but this one's still going to be the better investment because it has more money in it at the end. All right, so logarithmic functions. The logarithmic is the, let's go back here, the exponent, let's go back, that a base is put to achieve an answer, essentially. So this is called exponential form right here. Let's highlight it. This is exponential form. So b is the base of the exponent, x is the exponent, and then equals a is the answer. Lebesgue, log, you put the base of your exponent. Let's go back and see if I can make this a little bit smaller. Oh, they don't let me. So log, base, answer, equals exponent. Now, if there's no base of the log given, the base is 10. So write each exponential equation in log form. So essentially, what someone showed me a trick is that what you're going to do is you're going to switch these two places, their numbers, and you're going to put the word log in front. So if I do that, I have log 2, 64 equals 6. So I switch the place of 6 and 64 and I put the log in front. So for this one, if I switch the places of this and this, I am at log 4 equals 1. For example C, it's going to be log 1 equals 0. For D, it's going to be log, switch this and this, 0.04 equals -2. That 5 goes right there. Now one more. So this one's going to be log 381 equals x when I switch the x and the 81 places. So now we're going to go the opposite direction. We're going to write each exponential equation in log form. So this little thing right here, this guy right here, this is the base. Oh my goodness. Come on. There we go. That's the base. So it's going to be 10 to the power of 2 equals 100, your answer. And it should make sense to you. Let's change this to a 2 here, ladies and gentlemen. So this will be 7 squared equals 49. This one will be 8 to the -1 equals 0.125. This one's going to be 5 to the 1 equals 5. So now we're going to switch these back. These two, this goes here, and log goes away. This goes here, and log goes away. So we're going backwards now. All right, and last thing, how to evaluate logs. First, equals x at the end. We're going to put it in exponential form and then solve it. So remember, exponential form is b to the x equals a. That's exponential form. So for this one, we're going to write equals x. We're going to switch these guys like we did before. This goes here. That comes here. So we have 4 to the what power equals 4. X equals 1. My second one, so I'm going to write equals x. Now notice there's no base of the log, so we're going to fill in a base of 10. So we switch that 110 and drop log. So 10 to what power equals 100? 10 squared equals 100, so x equals 2. This one, again, no base. We fill in a base. We put equals x. We write it in exponential form. 10 to the x equals 1,000. Now, if we're asking ourselves what power x is, it has to be 3 because there are 3 zeros here, so that's the power that x goes to. If we go back to letter D, notice that there are 2 zeros, and that's the power x is to. So again, we're going to write equals x at the end. 4 to what power gives us 16? X equals 2. For E equals x. 2 to what power gives you 1? Anything to the power of 0 gives you 1. So you can put 1,000,000 to the power of 0 and it would be 1. And letter F equals x. 6 to what power equals 36? X equals 2. Great job today.